Okay, so we're going to be doing section 11.2 notes, which are probability distributions. And hopefully have a highlighter handy. And I'm going to be writing some stuff on here and also just kind of reading some of these things over. So probability distributions are pretty important because it measures the risk associated with particular events, assigns the probability, and then sees how those probabilities are distributed. And by doing that, it's possible to make predictions about what's going to happen in the future. So that's one thing we're going to be doing. Okay, we have to look at the two different kinds of variables. We have two different kinds. One is if we have a random variable x, it represents a numerical value assigned to the outcome of a probability experiment. The two types that we have are either a discrete random variable or a continuous random variable. So a good example of a discrete one would be the number of car accidents per year. You're not going to have 1.5 car accidents. And then a good example of continuous random variable would be number of miles driven, because you could have 1.5 miles driven. The different statistical techniques are used to analyze these two types of random variables. It's important to be able to distinguish between them. So for instance, down here we have the weight of cereal boxes. That's going to be continuous because you could have partial cereal boxes, so that'd be continuous. The number of cars in a parking lot, that's got to be discrete. Don't think you're going to have 1.5 cars in a parking lot. Number of people attending a dance, that'll also be discrete. 82.5 people attended the dance. I don't think so. Seconds it takes to serve fast food, that could be partial, that could be fractional too, so that's going to be continuous. So that concept's pretty easy. So our probability distribution is if you toss a coin 4 times, there are 4 possible outcomes: tails, 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 heads, heads, tails, or heads, heads. You can calculate the probability of getting 0, 1, or 2 heads from the sample space. A sample space is a set of all possible outcomes. That's what a sample space is. So the probability of getting no heads, if we look at this thing, there's only one way you can do that. So that's going to be 1 out of 4. Probability of getting 1 head is there's two of them where you have just a head. That'd be heads, tails, and tails, heads. So that'd be 2 out of 4, which is 1/2. And the probability of getting 2 heads is also 1 out of 4. Okay, so you can display the information on a graph or a table. And number of heads, 0, we have 1/4, 1 head, 2 1/2, and 2 1/4. And then we could look at the graph here like as a histogram or a bar graph. A probability distribution of a random variable x, is this key concept here, is in a table, equation, or graph that links each possible value of x with its probability of occurring. And so a probability distribution must satisfy the following conditions. First, the probability of each variable of x must be between 0 and 1. In other words, it has to be, if it's between 0 and 1, it has to be a positive fraction. And then the sum of all the probabilities for all the values of x must equal 1. In other words, the sum of all the probabilities equaling 1 is 100%. And if we look at up here at these probabilities for getting a heads, you get 1/2 plus 1/4 plus 1/2 plus 1/4. That equals 1, 100%. Okay. Okay, turn the page. We're on page 2 now, the other side. We're going to look at another example of a probability distribution. And so we have this situation. We have this teacher evaluation form. Students were asked to rate the teacher's explanations of the subject matter using a score from 1 to 5, where 1 was too simplified and 5 was too technical. So the simple one is down here, too simple. go in that direction, and then too technical was this end of it. Okay, so we're going to use a frequency distribution shown to construct and graph a probability distribution for the random variable x. X would be the score in this case. So we have, when they a number of people who scored 1, there was just one of them. Oh, by the way, we have to add up all the different frequencies to find out how many possible, or how many people actually did the evaluation. So there are 50 people. Out of that, 1 out of 50 scored it as just way too simple. And then number of people that scored 2, there were 8 of them, so that was 8 out of 50. And then number of people that scored 3 was 20 out of 50. The number that scored 4 were 16 out of 50. And the ones that thought it was just way too technical, that was 5 out of 50. So this 1 out of 50 is the same thing as 0.02. And 8 out of 50, or 4 out of 25, is the same thing as 0.16. And 20 out of 50 is the same as 2/5, or 0.40. 16 out of 50 is 0.32. And 5 out of 50 is 1/10, which is 0.10. And we're going to just add together all of those. And when we add all those together, we're going to equal, it should equal 1. And it does, 1.0. So if we check, that's our check to make sure that we did it right. So the sum of all of the probabilities of x should equal 1.0, or 100%. Okay, so we're going to try and find the mean of our probability distribution. Ordinarily, when you find the mean of something, for instance, coin tosses, you would just throw a bunch down and you would divide your result, or your total possible or favorable results, divided that by the total number. But you can't do that if you're going to be doing an infinite number of coin tosses, because you can't divide by infinity. So instead, we can use a probability of each outcome to figure out what the mean would be. So for instance, if we have an infinite number of tosses, you could expect that the probability of having 0 heads is still going to be 1 out of 4, and the probability of having just 1 head is still going to be 1 out of 2, and the probability of having 2 heads is still going to be 1/4. And so therefore, we can expect the average number of heads for many, or an infinite number, to be 4 times no heads, or 1/4 times no heads, plus 1/2 times 1, or 1 head, and 1/4 times 2, or 2 heads. You're going to get you're either going to get, these are the possibilities. You could have 2 tails, heads and tails, tails and heads, or heads, heads. Those are the only possibilities. So that one, or that one, or that one, that's when you add those probabilities, and you're going to get, the mean would be 1. So this is a method for finding the probability distribution in summarized below, which we summarize below. Oh, by the way, so this 1 means that when you throw down two coins, you should expect to get 1 head. That makes sense. So you could say that the mean of probability distribution, you multiply each value of x by its probability and find the sum of the products. We can use sigma notation here, but still, it all works out to be the same thing, where you could say that the sum of each x, the mean of the probability distribution, is equal to the sum of each x times its probability. Okay, so turn the page, we'll go to the next page. Okay, so let's take another example, find another, take probability distribution and figure out its mean. Let's go back to that example we did before with the teacher evaluation. And let's see, if we set this table up again, remember this side, it was too simple. The evaluation said that the explanations were too simple, and this end was, they thought that they were too technical. And the number of responses that thought they were way too simple, that scored 1, that was 1 out of 50, or they had a probability of 0.02. And people that scored 2 was 0.16. And the people who scored 3 were 2 out of 5, or 0.4. And people thought it was getting too technical was 0.32, and people thought it was way too technical was 0.1. And the scores that they got, people who scored 1, we multiply our x as a score, we multiply that times the probability, and we're going to get 0.02. And then we're going to multiply score x2 times this probability, which is 0.32. And people that scored 3, that score 3 had a 40% chance, so it's 1.2. And then 4 times 3.2 is 1.28. And 5 times 0.1 is 0.5. So if our definition is that the sum of each x times its probability is the mean, then this is each x times its probability, and we add each one of these up, and we get 3.32. So on our scale from 1 to 5, 3 is right in the middle, and 3.32 is a little bit to the right. So with a mean probability of 3.32, we could say that most thought the explanations were okay, I think, but leaning towards too technical. So the teacher could take that into consideration. Okay, so we're going to bring in a new term here for you, expected value. The expected value of E of x of a random variable for probability distribution is equal to the mean of the random variable. So you could say, therefore, that it's equal to the mean of the random variable. The expected value is equal to the mean. In this notation here, it says the expected value is equal to, this looks like an M. It's a Greek letter, and you'll hear it pronounced as mu, like a cat, or moo, like a cow, but the Greek way of saying it, the actual way to pronounce it in Greek is me. But you'll probably hear it mostly as mu. I'm thinking that. Anyway, and it means the mean. That's why they use an M. So the expected value is equal to the mean, which is equal to the sum of all of the x values times their probability. So just to recap this, because this is something you really need to know, that the mean of a probability distribution is the same as the expected value. This is key to doing your homework. You really need to know this. So when they're asking for the expected value, they're asking for the mean of the probability distribution. So here's a final example here. At a raffle, 500 tickets are sold at $1 each for 3 prizes of $100 or $50 or $10. You get 3 prizes. What's the expected value of your net gain if you buy a ticket? Well, we can figure out the probabilities for each one of these. So for instance, if you spend $1 and you win $1 and you win $100, then you've made $99. And so there's only one $100 prize out of 500 people, or 500 tickets. So that probability is going to be 0.002. And then if you win the $50 prize and you spend $1, then you've won $49. And that's got the same probability. There's only going to be one of those prizes. Only one person gets that out of 500 tickets. So that's also going to be 0.002. And if you spend $1 and you win a $10 bill, then you've made $9. And that has the same probability. 1 out of 500, which equals 0.002. This actually is a typo here. It should be you spent $1, but you got nothing. So this would be 0 minus, you got nothing and you spent $1. So that would equal not 0, but it equals -$1. So you're out $1. You didn't win anything. And the number of ways that you can do that is three of the 500 tickets were taken up by these first prizes. So it's 497 ways out of 500 possible tickets. And that equals 0.994. It looks like that's your best bet, that's what's going to happen with you. Raffles are usually not a good deal. So if we multiply our gain, these are the gains that we made, including the -1, times the probability. We have 99 times 0.002, and then 49 times 0.002, and then $9, that's how much we've made, times 0.002, and then -1 times 0.9994. If we add all these up, because that's what the mean is going to be, it's going to be the sum of the x times its probability. We add all those up, and we get a -0.68. So your expected value would be -68 cents. So expected value of negative $0.68 means that the average loss for someone buying a ticket is 68 cents. That's what they can expect to lose. Okay, I hope that helped a little bit.